Hey, unfortunately, our next speaker could not be here in person. This next talk is going to be from Zoe Ryan from NVIDIA. She's a solutions architect at NVIDIA working with higher education institutions and researchers. She helps them utilize their GPUs by accelerating their HPC workloads and adopting especially the NVIDIA Omniverse platform. And so she's going to be talking about the Omniverse platform and how you can build digital twins using this platform.
All right. Hi, everybody. I hope you can hear me. Let me get my screen starting to share. All right. Is everyone seeing my screen?
Yes.
Okay, awesome. We'll go full screen. Okay. Okay, great. Yeah, hi, everybody. My name is Zoe Ryan.
It's actually not in presenter mode. If you could swap.
I see. Let's pause the share. I'll switch screens. 1 second, sorry. Sorry for the delay. Okay. How about that? There we go.
Much better.
Thank you. Thanks for letting me know. Okay, yes. Thanks for having me today, everybody. I wish I could join in person. It sounds like it's been quite a full day for you all. Like mentioned in my introduction, I'm a solutions architect here at NVIDIA. I've been here now almost 3 years. And I primarily work with our higher education and research institutions on the West Coast. But with our Omniverse engagements, I've actually been working kind of across the US. And my focus areas really are on the robotics side when it comes to Omniverse. But I also work a lot with our HPC researchers using GPUs to accelerate their code there. So kind of two different areas of interest. But today I'm going to focus in on Omniverse as a way to build digital twins. I know we have an hour to go through this, and I'll try to leave some time for questions, but definitely feel free to stop me and ask questions as you go. There's quite a bit of material in this slide deck, but there's a lot of information I want to get to so we can talk about when it makes sense to use Omniverse and when it doesn't. So let's go ahead and get started. All right, awesome. So I don't know if you all have worked with or tried Omniverse at all, or if you've attended any of NVIDIA's GTC sessions, which is just our conference for developers. It's been online the last 3 years since I've joined, which has made it pretty accessible to higher education and research institutions. But one thing that you'll notice when we talk about Omniverse is that it's really a culmination of a lot of recent technological advances. Omniverse couldn't have existed 4 or 5 years ago. It's really a product of software and hardware, and in general, the 3D ecosystem coming together to now actually be something that can be viable and used by a lot of people. So on the screen here, we have 4 separate areas that have kind of grown drastically in the last 2 years that have really benefited the Omniverse growth that we're seeing today. So on the left-hand side, we have NVIDIA RTX technology. So I feel like every time I introduce myself to folks outside of the higher education community, and I say I work at NVIDIA, they all assume I know a lot about video games. And I fear I disappoint them every time, but working with Omniverse gives me some insight to the 3D graphics side, which is nice. So real-time 3D rendering has always been a part of NVIDIA's culture and a part of our solutions. But the focus now has shifted a little bit from looking good for a video game to being physically accurate, so we could use it for simulations. This means that the way the light actually interacts with matter is physically accurate and representative of the real world, which is important for digital twins. The next big change that we have is just compute levels have changed. Running simulations that used to be too large or too computationally intensive for a single GPU can now be done in the cloud or with HPC centers that you might have on campus. Just the amount of compute available as well as the size of simulations we're able to run has really changed the game for digital twins. And another thing you'll probably be sick of hearing me say today is that the development and the growth of USD has really changed the game for Omniverse. USD is Universal Scene Description, and it's actually an open source project started from Pixar back in, I think, 2015, which gives us a standard language to communicate our 3D design languages into each other. We can describe our virtual worlds with physically accurate pieces that build together into nice layers. And it actually kind of was a result of Pixar looking for a way to build out these massive 3D worlds, as they built USD as kind of an answer to the ever-growing 3D worlds that we're building. And then the last thing, I think the thing that probably drives all of us in attendance here today, is that the overall demand for AI and the AI revolution in every industry has really taken off. And the answer in a lot of ways is being able to run simulations that we weren't able to run before. And digital twins offer us one way in which we can do that. So these are just a couple of the pieces that really build up to us at NVIDIA working on Omniverse and trying to get folks to adopt the technology. So I'm sure today you've heard a bunch of different definitions and examples of digital twins. And for the sake of kind of cohesion on my end, I'm going to try to do an introduction of what we are considering a digital twin at NVIDIA, and we can see how that fits with what others have talked about or with your own interests. But a nice thing I like to kind of talk about when we're talking to universities about digital twins is that there's a lot of different scales to consider. It's not always just the city simulation that we're talking about for maybe urban planning, or like I just joined for part of the last conversation, and we see quite a few universities creating digital twins of their campuses, whether it's for autonomous vehicles or for planning new buildings. That's one of our more common use cases when it comes to when we're utilizing digital twins, but it can actually be at a bunch of different scales as well. For example, we can have it on the left-hand side. We have a molecular example. I could use to create a digital twin of human cells. This could help researchers predict how a cell will react to new drugs and accelerate the process of finding new treatments that would be difficult to do without the digital twin testing. On our next piece here, we have actually a demo or a small video at the end if we have time. It could also be something like an experiment or a lab, an industrial asset. It doesn't necessarily have to be a whole city. In this case, this is the UK Atomic Energy Authority, and their digital twin is of their fusion plant. So it can be some machinery or some equipment that you're using quite often. That could be a digital twin as well. We covered a little bit the city case. And then obviously there's kind of broad goals to have the largest scale that we can think of as far as a digital twin, which is our Earth 2 project, in which we're able to model and simulate weather patterns well into the future or well into the past to make more informed decisions about how we should handle climate change. So at every scale, researchers like yourselves are pursuing digital twins, and Omniverse can be a platform for all of these. It's just a lot about what data you already have and what you're going to bring to the table. So I just kind of wanted to pique our interest in places that we maybe don't traditionally think of as digital twins. These are places which we have NVIDIA researchers and community researchers doing work in. Okay, so when we're talking about a digital twin, I would just want to talk a little bit more specifically about how Omniverse fits into our understanding of what you're looking for. So obviously you don't see Omniverse listed here. We're going to go ahead and fill in what we're thinking of when we're talking about a digital twin in this context. So the number one things that we're talking about when we're talking about a digital twin is something that is physically accurate, AI enabled, it's a virtual simulation, and it's synchronized with the real world. So in this kind of basic drawing, we're looking to actually see the connection between our physical system and our digital twin. We're utilizing maybe real life sensors from the physical system to inform our digital twin, running simulations, and then actually making decisions in the real world based off that information. So kind of the flow of information is to keep these two in sync in a physically based, realistic setting. Those are our main goals when we're talking about digital twins. So when we're having all this exchange of information, one really important thing that I think probably most people have touched on today is how we keep the source of truth, or how we keep in sync with our real physical system. There's certainly different levels of fidelity of digital twins, starting at just a visualization component, going all the way to the real-time synced version of your digital twin. That's obviously our ultimate goal, and to get there, we have to have one central source of truth for all that information that's flowing between the two kind of systems that we're looking at, especially when we consider the fact that we might be utilizing these decisions made in the digital twin to inform real world decisions. We want to make sure we have up-to-date and synchronized information. So when we talk about this source of truth that connects the two, what we really want is an arbiter of whatever is current. So I'm not saying that the digital twin is necessarily our truth in general. What I'm saying is we want to make sure both of them are moving or making decisions based off the most up-to-date data. And the key here that is really useful, that we'll come back to later, is that USD has really clever ways of storing deltas and versions that allow collaborators to work together without having to forcefully upload and download changes that other teammates have made. So USD makes it kind of simpler for us to work off versions of the same code or off the same assets without causing some clashing or thrashing or relying on expensive uploads and downloads to some central repository. So when we go ahead and kind of zoom in either further, we're trying to just fill in the gaps here of what we're talking about for a digital twin. Let's take a look first on the physical system. So again, this could be some sort of physical object. It could be the COVID virus. It could be the whole Earth. Whatever our physical system is, we're hoping, and we're actually kind of relying on the fact that we'll have things like our virtual sensors or our physics-based models that we're going to go ahead and utilize information from. Our goal would be that maybe you're in a factory setting where you already have quite a few sensors deployed and you're already taking in that information and making decisions based off that. Our goal is to utilize all that valuable information, but in our digital twin now. So everything on the left-hand side, you can see it costs us something, right? It either costs us human wall clock time, compute time, or we're constrained to our physical environment. All of this can really slow down the decisions we make based on the information that we're given. So while we might have a lot of information in our physical system, it can be expensive, and it can also cost us a lot of time to actually make decisions based off that physical system. So what our goal is to combine all that information that we have in the physical system and utilize it in a digital twin. So once we have a digital twin set up, we're going to try to harvest that information that we're storing in that source of truth. And it helps that it's all centrally located in one area that is easy for us to access. A big kind of topic of conversation, something that I work with more on the HPC side, is even if you're not working on a digital twin, there's been quite a push for working on AI surrogate models for things that traditionally are physics-based models or just take a long time to compute. And having those types of AI surrogate models makes it much more efficient and also easier for us to run simulations that are much faster than they would be in the physical world. So it helps us take things that are batch mode jobs that maybe you're running overnight or takes a traditionally long time for you to get to an answer, and makes it much faster and also easier for us to keep humans in the loop. Instead of launching off a job overnight with an AI surrogate model, a human is involved at every step, and we're able to kind of make iterations or improvements as we go. So our main goal here, right, we're kind of filling in the two pieces, is to take all the valuable information you already have in your physical system, combine it in a single source of truth, and then utilize it on our digital twin side. So I know I kind of gave it away by skipping ahead in this slide, but now we're going to overlay Omniverse on top of this. So I haven't actually touched on the individual pieces of Omniverse yet, but the green is kind of highlighting where we imagine you might utilize Omniverse. And this main logo in the middle, our source of truth, as I've been referring to it as, is actually our Omniverse nucleus. And this gives us a place where we can gather all of our data together. It offers us a synchronization step, and it really is the key to Omniverse being a team collaboration tool, which is definitely something that's a big focus of Omniverse, and also that's something that allows you to use your digital twin for multiple different things. Maybe someone is working on a specific AI surrogate model and making predictions based off that simulation, and maybe another person wants to implement a robot that they have navigate through your digital twin. Those two projects can work together because we have this nucleus area that keeps us in sync and stores all our information. Another thing that this nucleus server does is it feeds into our Omniverse microservices, and also the different software components we have. So we'll talk a little bit about how Omniverse is a platform for developers to make their own microservices and their own apps. But the nice thing here really is that Omniverse feeds directly, Nucleus feeds directly into that, making our data readily available from inside our digital twin. So here's kind of the overall flow of information that we're thinking of when we're trying to utilize Omniverse for digital twins. This diagram looks loosely similar, but we're just plugging in a specific example. So here we have a factory digital twin. And on our left-hand side, we have our data that we actually want to input into our digital twin. We'll talk a lot about data ingest in a second, but we might have things, or hopefully we have things like the robot CAD or a factory CAD already available that we're using in some form or another. We're able to, with one step, get that CAD information and data into Omniverse with a conversion to the USD format that we talked about earlier, we'll continue to talk about it coming up in the future. But once we have that 3D data, that very valuable 3D data converted to USD, we're able to plug it into Omniverse to utilize for our digital twin. So I think at this point, it's worth noting that Omniverse is not intending to take over the tools you're already using for 3D creation or collaboration. Instead, Omniverse is providing one central location where you can use all your 3D data together, along with the other things that NVIDIA is known for, like our fast AI or our real-time ray tracing. So its goal is to bring together information from tools you're already using, not replace them. But what we have here, we're bringing in our CAD information, and then on the right-hand side, we have some goals of actually utilizing the digital twin, right? So we have, or I guess what I want to frame the right-hand side as, and frame our whole talk today is, what do you want to get from your digital twin? If there's not a specific answer to that question that you can't already get from your physical system, then this is a lot of headache for no specific outcome. But if we have a targeted kind of thought in our mind of what we need to accomplish with our digital twin, then that's definitely worth pursuing. So for example, factory planning, laying out factories and making sure they are compliant as far as regulations for employees go. And also maybe you're in an example of a car manufacturer, you're bringing up a new line for a different model of a car. Factory planning and layout is certainly an intensive job and one that requires a lot of attention to detail. And having a digital twin that we can do this type of factory planning certainly accelerates our process there. Another thing on the bottom here that we have that I think is super exciting is this integrates with our robotics platform. So what we can do is reinforcement learning with our robots in our digital twin to have them safely navigate through our factory floors. So in those two situations, it's obvious to me that we're trying to address something that currently our factory does not address without the digital twin. And then the bottom here, we have just kind of the pieces that we're plugging in that are relevant to mostly NVIDIA software. So path tracing, in general, your AI that you're already using NVIDIA software with integrates very well. MDL is our description for different materials. So making sure your materials have the right texture or colors. And then another thing is that we have our own physics module included. It's actually called PhysX, which does some basic kind of collision work. And also like you can do different blasts or explosions, but just integrates that real physics into your model. So here's just a first example of what we're talking about as far as digital twins in Omniverse. Okay, I know I've said a lot so far, and I apologize for not knowing if we were taking questions as we go, but if people have any, they can definitely put them in the chat. But now I want to talk about what Omniverse actually is as far as a technology. We're going to take the rest of the time in this presentation to go through each piece that you're seeing on the screen here, focusing mainly on Nucleus, Connect, and Kit. But I want to just introduce them quickly now. So Omniverse at a high level is a series of software components and tools that serve the needs that you might have when you're trying to build a digital twin, mainly kind of bringing together 3D content and bringing the simulation to life. So we've touched a little bit on Nucleus already. We'll go into more detail in a second, but that's our single source of truth, where we can store, share, collaborate on a project in real time. And this can work across multiple applications within Omniverse. So Nucleus is at the core of what we're doing when we're talking about Omniverse workflows. At this point, you might be thinking about your own 3D data that you have and whether or not you could actually bring it to Omniverse. And that's where our connector pieces come in. Connectors are a way to bring your 3D data into Omniverse. And it's really been a community effort. We'll look at the list of connectors that we have available coming up soon. But essentially what connectors are trying to do is provide a way to get from that original data tool into a version that Omniverse understands. That's USD, as we mentioned before. And that's kind of why it's underlying all these portions of Omniverse, because the real connection between all of them is having this standardized file format. In the middle here, we have Omniverse Kit. This, I think, is a really powerful area when we're talking about developers who are actually hands-on with building the digital twin. This is a place that allows you to build your own microservices, your own applications, your own extensions, and they're all done in Python. And it allows you just to extend the basic functionality of Omniverse. If you're to dive into a digital twin project today, Omniverse doesn't have every piece that you will need for your specific project. But what it does have with Omniverse Kit is a place that you can actually develop your own microservices, your own applications that fit your needs. So once you've gotten past kind of just your full fidelity visualization stage and you're trying to do maybe something more complicated that's not yet included in Omniverse, this is where you can actually do your development. And then on the simulation side, this is our suite of simulation capabilities. This is what really enables the 3D worlds that we have. We have the materials, the lighting, all of them to be experienced as you experience in the real world. So that's kind of the bread and butter of what NVIDIA has done for a long time, right? Real-time ray tracing, visualization, that's just bringing that component into Omniverse. And then on the right side here, I don't work on our drive simulation team. I know we just saw a talk about autonomous vehicles, and I don't really work specifically on that platform, but it is a part of Omniverse. But what we're focusing on here on the rendering side is that we can do interactive simulations, or we could do high-end fly-throughs. So perhaps you've worked really hard on a digital twin, and you're presenting it to a different research group or to a community that's not as involved on the simulation side. You can do some really beautiful rendering within Omniverse to do high-end fly-throughs of your digital twin and inspect each piece as well. One thing that's coming to our RTX rendering side is VR and AR. So we have some beta forms of that already where you can explore through your digital twin and a VR headset, which can be really powerful when you're working with a big 3D world. So these 5 components kind of make up the end-to-end cycle of anything you would want to do in Omniverse, but today we're just going to focus specifically on the digital twin piece. Okay, so I've talked quite a bit about USD already, and I don't know if folks are already using it. I think we see it quite a bit more on the media and entertainment side, just since it came out of Pixar. It's just more widely adopted on that end, but a nice thing is it is gaining some steam on the 3D visualization side as far as it goes to digital twins and robotics as well. But USD is really what makes Omniverse work in the long run. It's our scene description language. Again, it's originally developed by Pixar for expanding and building those massive 3D worlds that they're known for. And the reason that it's so powerful for that type of visualization is because there's an easy interchange between assets in various software applications. So maybe you have someone who's working in Revit and someone who has CAD files, and they never have been able to use them together just due to the nature of the different file formats. USD, along with Omniverse, gives them a way to bring that data to one spot. And in kind of a cheesy comparison, whenever we at NVIDIA are talking about USD, we often bring it up as USD is the HTML of the 3D world. And I mean that more on the lines of it's ever evolving. We obviously don't use original old HTML anymore on the internet. And the original format of USD is also not really used anymore. It's something that the community is contributing to. It's highly extensible by design. The nature of it is to bring any data you have and have it fit in the USD format. It has different schemas that make it universal among different applications, and it standardizes kind of what it means to be a USD format. So extremely powerful, certainly growing. I think it's very rare that I've worked with a higher ed customer who already has all their data in a USD format, because that's just not what we're used to seeing. But that's certainly where the connectors come in. It's just one piece that makes it a little bit easier for us to get everything working nicely together. Okay, so once we have USD, once we have our data in the USD format, we're bringing it in from our applications, we want to go ahead and utilize Nucleus. So let's talk a little bit about what that means. So this is our way to collect all the data. I think it's common knowledge that the data for a digital twin is the trickiest part often. It feels like almost an impossible task to build a digital twin if you aren't already working with 3D data. But a lot of times when we're in a situation where we have 3D data from all different places, getting that into one spot can be actually fairly tricky. But with Omniverse Nucleus, we have a universal asset exchange. Typically, you would think of needing to upload and download to get changes that others have made in your research group or others who are working on the same digital twin. And this can create a lot of duplicate data, but the goal of Nucleus is to avoid that type of overlapping in versions based on upload and download. And the goal is really to streamline the fact that users can send, publish, and subscribe to file changes. So if someone on your team is making changes to a portion of your USD, a layer of your USD file, you can subscribe to the changes that they're making every time they're published, making it just a little bit more streamlined to actually work with the data. And when you do that sort of subscription, what you're doing is you're receiving the deltas or the changes in the USD, not the whole file. These USD files can be huge. And so working with the deltas is a really powerful tool and just avoids that lengthy upload and download that we could maybe might be a problem if we're working with big data in general. And then another nice thing about working with USDs in general is they keep versions in layers, making it easier to make non-destructive changes. So if I'm working on one layer, that's maybe the greenery or the trees of a digital twin, I can make changes without affecting a layer that's focused on the buildings. Just gives you a good kind of easy way to build upon the layer by layer pieces. And then another thing that we're trying to look at or focus in on this diagram here with the two client applications is that we can have multiple connections to that same model or that same USD that we're using that different people in different places can go ahead and utilize, which makes Omniverse really extendable and able to scale out. When we talk about or when we talk to research groups interested in building digital twins and they're not sure where to start, oftentimes it's one person who puts in the hours on a single Omniverse instance to get their 3D data loaded in and see if it works for them, right? It's not for everyone to use this tool, it's just one of the many tools you have available. So a great first step is really to get in with one person trying out Omniverse. But obviously, if there's traction there, there's going to be growth on the team and more folks involved. And the nice thing about Omniverse is that it does scale where you always can come back to this central location with the Omniverse nucleus that will have all of your data. So the goal here is to highlight that you can have different folks working on the same data with relative ease. And I think that's a big selling point for any part of Omniverse that you might be interested in. It works on the robotics side, it works for the digital twin side. Definitely a powerful portion of the Omniverse kind of software that we're talking about today. Okay, so that's all I have for the nucleus section. So at this point, if we're thinking of this as kind of a life cycle of a digital twin, what we've done so far is we've installed Omniverse, we've thought about all the 3D data we have available, we've seen if there's a connector, and we've set up our Omniverse nucleus server so that our team can work together on the same data. And at this point, what you might be wondering is, how do I know if my data can be easily converted and utilized in Omniverse? So that's where these connector pieces come in. So here's a little example of when we're zooming in, how we might actually connect our data to Omniverse, right? So an important piece about Omniverse is it really began in the community and is still well supported by those who are deeply integrated in the 3D visualization community. Prevalent applications in 3D visual effects in the 3D visual effects world are certainly contributors and collaborators in the Omniverse project. And what connectors do is allows them to put their data in the USD language, which is something that Omniverse speaks across the application. So highly recognizable names here on the left-hand side. We've got Blender, Unreal Engine, Revit. I feel like when I'm working kind of with our schools in architecture, we get a lot of folks working with Autodesk Revit, our CAD models, or Rhino also. And these are just a couple examples of places where your data might be coming from. And then once we move that data, utilizing our connectors into Nucleus, then we have our collection of microservices that allow us to either scale up the cloud to a supercomputer or to other hardware. And one thing I really haven't touched on much, which is interesting given I'm from NVIDIA, is we haven't really touched about like the GPU accelerated nature of all of this. There's a lot of underlying work done to Nucleus that's abstracted away from us that allows it to scale efficiently utilizing the GPU hardware as far as like database access and things like that. So just a hint at the amount of work that folks have done under the hood to optimize that. And then once we're actually in Nucleus, we have our data converted. There's quite a few different ways for us to visualize our work with that data. So Omniverse Create and View are just two other pieces of Omniverse that allow you to look at, interact with, play with the data that you have. And then you can be visualizing that on a workstation. So something with your GPU, VR, like I mentioned before, augmented reality, kind of along the same lines. And then there's even a web browser, which allows you to do effective demos to folks who are interested in the 3D work you're doing. So maybe you have your digital twin, or maybe you literally even just have the 3D data from Revit imported into Omniverse, and now you have some beautiful lighting, real-time ray tracing, and easily interactable. You can utilize just a web browser to view that data and show someone in a meeting setting, for example. So there are a couple different types of connectors or methods in which you can connect your data to Omniverse. On the top hand side here, we have the actual connectors, and there are two main types here, the bidirectional connector and then our unidirectional connector as well. So a bidirectional connector is kind of the most interchange of information that you can get. And that's where you get real-time updates between both applications. So between the application you're starting with and Omniverse in real time. So I make a change in Omniverse and then I see it in my home application as well. So that's really powerful. The material conversions are supported as well. So materials you have in your beginning application are supported once you get to Omniverse. And then on the other hand, we have the unidirectional connectors, which reflects real-time updates in Omniverse, but the updates in Omniverse are not shared back to that original application. So that's a one-way street from your starting application into Omniverse. And then on the bottom here, we have kind of just the automatically Omniverse connected. Things that are already saved in the Nucleus server are immediately uploaded and easily used in Omniverse. You can do some native export and import from things that are automatically converted to USD. And then your extensions that you're working on, your Python extensions that you're writing in Kit, those are just simply added in or accessible to you from Omniverse. So two main sections, both of them give us a way to bring more data into Omniverse. That's kind of our goal here, is get all the data there and then we can really begin working. One thing I haven't mentioned that I think if you were to look at Omniverse kind of demonstrations or tutorials in general, is that the shared Nucleus server that comes installed with Omniverse has some 3D assets that you can use. If you've ever watched any of the GTC demos or the keynote, whenever they do kind of 3D visualization work there, all of those assets are then made public for anyone to use. So if you're looking for just kind of getting started with an environment and some 3D assets, there's quite a few already available on Omniverse that are already in the USD format. So you can get a sense of what it looks like to work with that type of 3D data. And now we're going to look at an admittedly ugly slide, and a slide that I think is probably perpetually out of date because it's changing every time I present, but I always try to bring the most up-to-date version. These are the connectors in the community that are working with Omniverse on this kind of standardization to the USD file format that we've been talking about. Last time I checked, there was over 40 ISV partners working with or on connectors today. So there's quite a bit of coverage. And I think a year and a half or 2 years ago, when I started talking to universities about Omniverse, I really struggled with this portion of the conversation because so many folks didn't have data in the applications we supported yet. So it becomes a little bit easier and a little, the use case for Omniverse is more straightforward when you see all of the connections we have to these industry partners. There's quite a few on here, and then there's also an extensive list online. They actually have a spreadsheet that's publicly available of kind of each portion of the application, what's supported. So if that's something you're interested in looking at, I can link to you guys to that afterwards as well. You can see they're sorted by the types of connectors that we were talking about before. So direct imports can be done with all of those bottom file types. And I think that's always actually really nice. I feel like I'm consistently surprised the number of times I can just import the type of 3D data that I'm interested in directly into Omniverse. I think that's pretty convenient. And then on top of that, we have kind of the connectors that I was talking about before. So I think that a lot of times people are asking or have been working with Unreal Engine, and I think it's always really fulfilling to see that that's a bidirectional connector that works really well to and from Omniverse, and is certainly very powerful as far as there's a ton of 3D data being utilized in Unreal Engine today. So again, this is just to speak to the fact that Omniverse is not a replacement for the 3D tools you're using. And it also, I think, speaks to the amount of work that you'll have to do with either a 3D artist or someone really well acquainted with 3D data in order to make a full-fledged digital twin. The last thing I wanted to talk about is that if you're doing some sort of scientific visualization, I don't know if that's an interest of folks here or for folks on more traditional digital twins, ParaView has an integration with Omniverse that is really powerful, that goes past just this unilateral or unidirectional, connector listed here. So if that's something you're interested in on the scientific visualization side, it's certainly very powerful within Omniverse. Okay. So now we're moving on to the kit portion. So at this point, you have taken your data from the 3D application you're using previously. You've found the connector that works, and you've brought your data into Nucleus. Maybe you're even pulling data from outside of your own work from the Omniverse Nucleus server. And now you're trying to do some of your own integration into this simulation. So that's where Omniverse Kit can come in. This is where your developers will go to work on advancing your projects even further. So If you're on the visualization side, you're going to do less work here. But if you're a Python developer, this is definitely where you'll spend quite a bit of time. So I think we really want to keep in mind when we are talking to universities about Omniverse, that it is a platform to do your own development on. This is not a plug in your data and you get a digital twin out of it. There are obviously a lot of pieces and components and work that goes into it. One of those is on the development side. But the goal really with Omniverse and with Kit in particular is to provide small building blocks that you can then reuse in a lot of different assets when you're building your own portions, when you're building your own microservices or extensions, whatever it has you. So the modularity is really the most important piece here, trying to make it customizable and really ease the overhead of trying to build these different combinations for your specific digital twin. I hope, usually we say that it's working mainly in Python and people are excited to hear that, but you never know. But the goal here is to be able to quickly build powerful tools and then distribute them to other content makers, package them into microservices, or just kind of empower other people to do similar workflows to the one that you're doing. Omniverse has a ton of built-in reference applications. In fact, when we're talking about code or create or Kit, those are all just applications that are built on top of this shared Omniverse framework that we're talking about. But they give you a great jumping off point as far as a place to use or look at your data. And then the other things that we have here, I'm not going to talk too much about it, but there's OmniGraph, which is a graph-based editing framework to develop your own kind of custom behaviors, extensions, or apps. That's what we're looking at here in the middle. And on the left, I know that's blurry. I'm not sure why that looks like that. I'm sorry. But yeah, the graph-based portion of Omniverse is how a lot of our own SDKs and applications are written and gives you kind of a more visual way to connect information within Omniverse. There's great tutorials online for using OmniGraph. And then another thing that I don't want to ignore is that Omniverse doesn't exist in a bubble as far as NVIDIA technology goes. It's one piece of the broader puzzle as far as NVIDIA software. So there's quite a few microservices that pull in information from other SDKs that we have. So for example, Modulus is one of our frameworks that is relatively new, which you can pull in information from Modulus into Omniverse as a small microservice that you're utilizing within the application. So if you're a developer wondering if this is a good platform to maybe try to bring your AI surrogate model for your digital twin, there's certainly quite a few options you can pursue as far as development here. And these are just a couple ways in which you can go ahead and get started with it. Okay, so when we're talking about Omniverse and using it for digital twins, the goal is to streamline the process that is, at this point, pretty scattered in a lot of different directions. We definitely have higher ed and researchers who are already successfully building digital twins, but oftentimes it's kind of a scattered process that requires a lot of different technologies, and we're just trying to streamline that and make it easier to work together or iterate it on your digital twin as a team. So a lot of times what takes the most steps in this type of process is a single aggregation of all your data, but instead we can do that as a continuous process when we're utilizing Omniverse. And the goal here is to have fewer places in which there's one portion of this process that's blocking the rest of the project. I think as a solutions architect at NVIDIA, whether I'm working on Omniverse or working on our HPC applications, the goal of utilizing the GPU and utilizing the software around it is always to find the bottleneck and see if we can accelerate that in some way. And so the goal with Omniverse is definitely trying to make the iteration and evolution process less bottlenecked by data aggregation or having other folks work on the same data. The goal is to be able to do that seamlessly, giving you the ability to review at every step as opposed to having to wait till the end. Basically just giving you that asynchronous option to work together on a project. And then here we have just kind of the cycle that I think this is really informative when you're deciding at what stage you're at with your digital twin, whether or not you want to enter in trying to use Omniverse. It gives us a view of the different entry points that you really have. Not all digital twins are built in the same way, and not all digital twin projects start at the same spot. It really depends on the different competencies. Maybe you're focused mainly on the science side and the programming Python extensions is not something that you'd be comfortable with. That's one thing to consider. Or maybe you have a lot of 3D artists who already have these beautiful 3D assets for you to use. but then it's going to be more difficult when you get to the like integrating autonomous system side. There's definitely different configurations of groups working on digital twins, and this is trying to highlight how that cycle would actually work. And there are kind of 4 different pieces that break down the creation of building a digital twin at a high level. So I think kind of first and foremost what we have is the full fidelity visualization. And I often think that this in many ways is where people think they have a digital twin, but you're not fully there, right? Or oftentimes some people are thinking that's the full extent of a digital twin. And that's at the point where we've aggregated our 3D data sets, we have the right materials, the right lighting, and we're able to visualize them in real time. So this is often our goal, is that you're able to start at this point where you already have the 3D data sets, and then with Omniverse, you're able to bring in that real-time visualization. But this is really just one step in the process of the full fidelity digital twin that I think we're all searching for and trying to build for ourselves. I think that a really big key, though, with this full fidelity visualization, like I talked on the first slide about, is the fact that we're now able to scale to different compute sizes. We have more resources in general as far as GPU goes for visualizing massive scenes in real time, and also with the power of USD, making it easier to integrate multiple data sources into one spot. We're able to reach this full fidelity visualization stage faster when using Omniverse. And then the next kind of piece we'd want to add in is the physics simulation, bringing life to the digital twin instead of it just being something that's beautiful and real-time rendered, adding in kind of the physics to make it realistic, make it real. Our goal with this most of the time is to add in real-time sensor inputs from our real world or real-time simulations that would mimic that type of sensor input. That can all be done through different microservices within Omniverse. And this is what really takes us from a visualization into something that is a digital twin, something that is really informed by the actual physical place that we're modeling, as opposed to something that is just a representative or a visual representative of what we're looking at. Sensor inputs are obviously a really big piece of this. Constantly streaming information into your digital twin, feeding it up-to-date information is really what makes it powerful for making informed decisions. Having a connection to that IoT sensors or to our industrial automation processes that we already have is really important when we're thinking on the scale of buildings or cities as far as digital twins go. And then our next piece would be adding in autonomous systems. This is maybe not always relevant to every digital twin, but when we're thinking about it, maybe in the sense of a factory floor, adding in these kind of autonomous robotic systems, operating in the same space at the same time, helping us optimize and operate our virtual twin and make sure that we're able to test things prior to bringing them into the real world. That allows us to utilize the transfer learning from our digital twin into the physical world. So that's the kind of next step as far as adopting AI into our digital twin, is introducing these autonomous systems, seeing how they perform in our digital twin, and then utilizing that information in the real world. I want to make a quick diverging point, but one that I think is relevant to this point here, is there's a piece of Omniverse where we're able to actually generate synthetic data as well. It's called Omniverse Replicator. I actually recently taught a course at GTC about it, and there's a blog post if you're interested, but we use synthetic data generation for training AI object detection models. But you can also imagine that something that we're working on is Replicator for robotics. So in which you can train multiple versions of the same robot in unlimited scenarios to quickly train it to move around and work in its environment. So generating data and integrating autonomous systems into it is certainly a key component of Omniverse, and one in which there's quite a bit of work being done. And then at the end, our real goal is to connect to the real-time streaming of data from the physical twin to our sensor models and iterate on this process. So that's kind of the life cycle of working on a digital twin, and you can imagine entering at many points throughout this cycle. Okay. I have a demonstration here also of some work that I think is cool, and also a use case I mentioned at the very top of the hour. It's a fusion reactor, a digital twin that is physically accurate and also has the internal reactions modeled. So one thing I said that we'd want to think about when we're framing why we want to consider a digital twin is, what do we learn from a digital twin that we can't learn from the real world? And seeing the internals of this fusion reactor modeled is something that we're not able to do with our real reactor. So this is a collaboration with UK Atomic Energy Authority and also the University of Manchester, I believe. And the goal here is to accelerate their development on the reactor. And they've included all the components here, including the plasma, as you can see internally. The goal also is to control the amount of maintenance they need to do on the system and have an idea of when they'll need to do that upkeep. And then I think a cool piece here is while the 3D data is something they already had that they imported to Omniverse, they did need to actually do a little bit of development on the other side of that. They created their own extensions for actually some simulation software that they were utilizing specific to the plasma reactions. So the neutron transport that's being done inside the reactor core is done in a specialized application that we didn't have support for, but they went out and wrote their own extension to utilize that software in Omniverse, which allowed them to actually see the internal plasma transport being done. So let's see if we can get this to play. It's just a quick video. Let me try on this screen. There we go. And they've made the outside glass to see the internal reactions. You can see the lighting is done. And then we'll actually get the idea from the inside. Anything of that bright glowing color is the actual simulation that they traditionally did in a specialized software. They're now able to visualize and see within their digital twin. So it gives them an idea of when maintenance needs to be done, how the fusion reactor is actually working, and also lets them try out new designs that would be extremely hard to try out in the real world. So I know it's a short video. There's actually an article published online about this, but I do think it's a cool culmination of the types of topics that we were talking about today. Okay, I'm going to try to leave some time for questions. So I want to just have two more things to say. I just spoke a lot of stuff about Omniverse to you, but if there's any piece of this process you're interested in, if there's a connector you're looking for, if there's something outside of a digital twin that you're interested in, you're not sure where to start, there's a lot of training material out there on Omniverse. Most of it is just within the Omniverse install itself. There's also a pretty great YouTube channel for Omniverse tutorials if you're looking to get started. And you can also just install Omniverse on any desktop with a GPU. If you have your consumer grade card, if you are working with some workstation for your lab, you can install Omniverse that way. And there's free individual licenses for anyone to use and try it. We could do it today if you're interested. But yeah, great tutorials out there for getting started as well. So with that, I have extra slides if there's other questions or information you're interested in. But I wanted to leave time. I think we have like 5 or so more minutes for you all to ask questions. And again, I apologize for not being in person. I wish I could be there with you all. I know it's much better to do these events live, but I'm excited to join anyways. I can also pull up the chat if there's anyone on Zoom who is interested in asking questions.
Are there any questions?
Hi, yeah, thank you for the very detailed presentation on Omniverse and everything surrounding that. What, you know,
Try this one.
Here we go. Okay, take 2. The other mic wasn't working. Hi, thank you for the presentation. That was very nice, walkthrough of Omniverse and how all the different components there. In a university context, could you maybe speak more on what using these tools that you've talked about with Omniverse and the different components, what that looks like in a university context on, an HPC, a local HPC system?
Yeah, that's a great question. So I only touched briefly on how we usually engage with these types of interactions, but what it usually is we get involved with one person on the research team who's extremely interested in either a digital twin or maybe the robotics piece, and they'll install a local version of Omniverse Launcher onto a workstation or like an RTX laptop that they have, something just to try it out. Omniverse Launcher is just where you can get any of the software from. And then there's an individual license that's free. And then usually if they're continuing to do work with the rest of the research group, we'll see kind of one of 2 things. Either they have some kind of one-off workstation that a lot of them are utilizing, and then they'll install Omniverse Launcher in which they have all access to the same Nucleus server, and that kind of gives them the collaboration piece. Or we have seen actually recently quite a bit of adoption as far as having some visualization nodes maybe in your HPC clusters. So if you have any like RTX 6000s or anything kind of along our RTX line, you can have an Omniverse installed there that folks can either access through like WebRTC, or there's a couple of different options there to utilize the GUI. The problem with that type of install is it is very visual, so that's a little bit of added kind of fickle part of utilizing it there. But I would say those are the two main ways in which we see it, is either kind of a bespoke workstation install, which the team works on, or if there's growth at the university, having a portion of your more visualization focused GPUs working there. Does that answer your question?
Yeah, no, that was great. Thank you.
I think there's also one in the chat that's asking about whether it makes more sense or whether it's more typical to run it locally, or how it just fits in the overall HPC environment. I think NVIDIA as a whole has made a push towards cloud recently, but I think we're seeing less adoption of that as far as our higher ed researchers go. So I think the most common ways in which we see people running it in the higher ed space is locally on any workstation that they have available. And then what we've seen also is if a whole university has quite a bit of interest, we have these things called OVX servers, which are just our best visualization GPUs in a single rack with dedicated storage for your Nucleus server. So that's kind of like, if you're really interested, that'd be another option. But yeah, great question. It's definitely a little bit different than our more traditional kind of HPC stuff that we
Switch
have.
it to the participant screen. Okay, thanks. I think we have maybe time for one more question. So anyone either here? Oh, here on.
Thank you very much for your talk. So I noticed from previous years, NVIDIA GTC and Jensen Huang has been presenting this drive scene, which is something of our interest. So I'm just curious, this drive scene is part of the Omniverse, or it's like a side project? And also, like universities, how do we get access to that drive scene?
Yeah, so great question. Within Omniverse, there's kind of three main components. We have the main Omniverse, we have our Isaac Sim for robotics, and then we have Drive Sim. And that's kind of the specific portion of Omniverse software targeted for autonomous vehicles. The underlying platform of Drive Sim is the same as far as Omniverse technology. However, access is still currently limited to like early access programs. And recently we had folks down at UTSA who were doing autonomous vehicle research, and I went and requested access from our Drive Sim team. And at this point, they're still working with just industry collaborators and not yet higher education institutions, unfortunately, even if they're doing industry collaboration. So although like the AV side is definitely a big focus for us as a company, currently we don't have that software accessibility for higher education. I'm certainly interested in when it becomes available for researchers, because I think that would be really progress the software as they give access to researchers, but it's just not happening yet. I'm more than happy to keep in touch about when it does become available, because I think there's a lot of interest from the HER community for that. But the main answer here is that the technology underlying is the same. There's just some specialized components on the Drive Sim side that I'm honestly not privy to, but it's definitely built on the same underlying information. So for example, I mentioned Omniverse Replicator, which is our synthetic data generation tool. That's the same for our drive simulation team as it is for the Omniverse team. It's just obviously focused on a different area. So yes, there's still a ton of work being done there. That's obviously with our industry partners like Mercedes, that they do almost all of their work and not necessarily on the research side. So kind of an unfortunate answer because we do hear about it a lot, especially at GTC. And we see the cars driving around campus all the time, but it's just not on the research side yet. So great question.
All right, well, let's thank Zoe.
Thank you, everybody.